Hey folks, welcome back. In this video we're going to go over 5 worked examples to show you how to do problems involving polarization by reflection. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. Question 1 says, describe what is meant by Brewster's angle. Well, remember from the notes we can define Brewster's angle in 2 ways. So we could say that Brewster's angle is the angle of incidence which causes the reflected light to be fully plane polarized, or we could say it's the angle of incidence at which the angle between the reflected and refracted rays is 90 degrees. Question 2 says Brewster's angle for a liquid is 52.0 degrees for a particular wavelength of light. Calculate the refractive index of the liquid for this wavelength. Well, writing down what we know from the question, we're trying to find refractive index n, and we know that Brewster's angle IP is 52.0 degrees. So writing down our equation relating Brewster's angle and the refractive index, we have n equals tan IP. Substituting in the number here gives us tan of 52.0, and if you put that into your calculator, you should get an answer of 1.3. Question 3 says water has a refractive index of 1.33. Part A says at what angle will unpolarized light reflected from the water be fully plane polarized? Well, we know that the reflected light is going to be fully plane polarized when the instant light is at Brewster's angle. So we're trying to find Brewster's angle here at IP. And we know the refractive index is 1.33 for the water. So let's write down our equation relating refractive index and Brewster's angle. We've got n equals tan IP. Substituting in the number gives us tan IP is equal to 1.33. And then we need to do the inverse tan to find IP on its own. So doing inverse tan or shift tan in your calculator of 1.33 should give you an angle of 53 degrees. Part B then says to determine the angle of refraction inside the water at Brewster's angle. Well, remember from our diagram of unpolarized light reflected from a water surface, we could say that at Brewster's angle, the angles on the right hand side all total 180 degrees. So we have Brewster's angle IP plus 90 degrees plus the angle of refraction R is equal to 180 degrees. And this is asking us for the angle of refraction R. So if we sub in our Brewster's angle now for IP, we have 53 degrees plus 90 degrees plus R is equal to 180 degrees. So if we then subtract 53 and 90 from both sides, we end up with R is equal to 180 minus 53 minus 90. And if you put that into your calculator, you should get an answer of 37 degrees. Question 4 says an unpolarized light ray in air reflects and refracts on contact with a transparent material of refractive index 1.38. The reflected light is plane polarized. So there's your air and your denser material and the boundary between them, then get the normal labelled there and the unpolarized light coming in and reflecting and refracting, and we're told this light is plane polarized. It then says on the above diagram, write in the values of all the angles, use the space below for any working. Well, since the reflected light is plane polarized, we know this is going to be Brewster's angle in here, IP. So let's try and find what that angle is. So we could say IP is what we're trying to find, and the refractive index n is 1.38. So let's try and find Brewster's angle IP here. So using our equation, we have n equals tan IP, and just swapping the sides here, so we have tan IP on the left, this gives us tan IP equals 1.38, and then finding IP on its own, we need to do inverse tan or shift tan of 1.38, and if you put that into your calculator, you should get an answer of 54 degrees, so we can label that in our diagram there. And because this is 54 degrees in here, remember this ray is going to undergo the law of reflection, so by the law of reflection, this angle must also be 54 degrees. We can then label the angle between the reflected and the refracted rays because we know that's going to be 90 degrees. Now to find this angle in here, remember we can use the idea that all of these 3 angles must total 180 degrees. So if we want to find this angle, we could say that at Brewster's angle, IP plus 90 degrees plus R is equal to 180 degrees, where we know that IP here is the 54 degrees. So let's sub that in, so we have 54 degrees plus 90 degrees plus R is equal to 180 degrees. And then to find R on its own, we can subtract the 54 and the 90, so we get R equals 180 minus 54 minus 90, and putting that into your calculator should give you an answer of 36 degrees. So that means we could write in our 36 degrees here. And then obviously here we've just got another 90 degree angle, and we can work out what this angle is here because we know that 54 plus this angle must total 90 degrees. So we could do 90 minus 54, which again just gives us 36 degrees in there. And that's us completed all the angles here, but if you wanted to be a wee bit more specific about these 2 angles, you could just write in that that's your 36 degrees in there, and that means that this is your 54 degrees as well. But you don't have to add those in if you don't want to. Lastly, question 5 says an unpolarized light ray refracts into glass and is also partially reflected as shown below. So you can see we've got air and then glass and the air to glass boundary, and we've got the normal labelled there as well. And we're told that this angle of incidence is 51 degrees and the angle of refraction is 31 degrees. And it's asking, is the reflected light plane polarised? You must justify your answer. Well, to work out whether the reflected light is plane polarised, we need to know whether the angle between the reflected light and the refracted light is 90 degrees. So let's start by labelling some of our angles here. So we know that by the law of reflection that this angle must be 51 degrees, and we have the angle of refraction is 31 degrees, and we want to find the angle in here. So we can do that using these two angles and the fact that all three angles here must add up to 180 degrees. So let's label this angle that we're trying to find and let's call it x. So we could write this as 51 degrees plus x plus 31 degrees is equal to 180 degrees, i.e. all of these three angles must total 180 degrees. And let's try and find x on its own. Now if x was 90 degrees, then that would mean this reflected light is fully plane polarised, but if it's not 90 degrees, then it means the reflected light is not plane polarised. So if we rearrange this for x, we can subtract 51 and 31 degrees from both sides, so we get x is equal to 180 degrees minus 51 degrees minus 31 degrees, and putting that into your calculator should give you an answer of 98 degrees. And therefore we can conclude that since the angle between the reflected and refracted rays is not 90 degrees, the reflected light is not plane polarised. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.